Bring it up slowly. We can't risk any more damage to the casing. The corrosion analysis starts the moment it's secure. The laser allows us to remove the calcification without damaging the underlying structure. It's precise work. This engine block is heavily compromised. We're looking at severe marine-induced degradation across the main structure. The induction heater applies intense, localist heat, allowing the team to finally break free this seized landing gear bolt. Everything must be carefully logged and arranged. This crankshaft alone has 22 separate pieces.
Quá trình này rất hiệu quả. Chúng ta đã tìm thấy số series gốc.
Using the laser cleaner allows us to meticulously remove the rust without damaging the underlying structure, preserving this piece of aviation history.
The gear profile is loaded. We are transferring the CAD sequence now to the main fabrication chamber.
We're monitoring the melt pool closely. This titanium gear is crucial for the wing assembly. The structural integrity looks good. This titanium alloy is perfect for the planetary gear replacement. We have to lower them slowly. The reaction is immediate. Look at the color shift. This seals the metal against further rust. The black oxide treatment creates a durable, corrosion-resistant finish, crucial for preserving these salvaged components. After cleaning, we use a microfiber cloth to bring out this deep, glossy sheen and protect the surface from future corrosion.
Slowly now, ease it down. We need to feel the bearing seat correctly before we rotate the shaft.
Bôi trơn bằng dầu có độ nhớt cao, đảm bảo hoạt động trơn tru. Bộ bánh răng này cuối cùng đã sẵn sàng.
We apply the torque in a star pattern to ensure even pressure. Wait for the green light and the chime to confirm military specifications.
Vibration levels are nominal. All parameters are holding steady within the targeted bounds.
After months of work, the Allison V1710 is finally complete. We're ready for testing. The cross-section confirms the dimensions exactly. This is definitely the starboard engine mount, matching the recovery data. We finally finished the coating process. The brass clips really shine now against the black oxide.
Keep the pressure steady around this section. We believe the stamp is located here.
Incredible. That confirms it's the 75th Squadron aircraft. If we cross-reference this section here on the blueprint with the salvage piece, the deformation matches the impact zone.
Exactly. The microfractures confirm the stress point.
That looks like the serial number right there. The scanner is picking it up now. Let's see if we can get a clear reading. The data confirms the designation. The corrosion on these gears suggests prolonged submersion. The engineer is now taking precise measurements to assess the structural integrity. Based on these blueprints, the main spar should be just below this section. That explains the localized corrosion we're seeing. Look at the stress fracture right here near the rivet line.
The corrosion is significant, but the structure seems compromised internally as well.
Look at the insulation here. It matches the 1944 specification.
Yes, and the serial number confirms it.
Look at the serial number here. The marine growth actually preserved this section. We need to scan this immediately.
The corrosion here is extensive, but the laser seems to be working. We need to check the structural integrity of this rivet before we move it.
Look here. This marking confirms it's the lost Corsair. Bureau number 7645.
Look at the serial number here. It confirms the date.
Yes, and the stress fractures indicate a high-speed impact.
If these trays align with the manual's part numbers, we finally have a system for the cockpit components.
Cutting complete on section 4. Copy that, moving in to measure the impact point now. Maintain position, Charlie. I'm going to clear this section.
Acknowledged. The ROV is showing a serial number at frame 7.
Careful with that section, we need to preserve the serial number underneath.
Roger that. Switching to the smaller tool now.
Look at this serial number here, just beneath the rust. I'm getting a high-res scan now. It looks like the squadron markings. Look at the stress fractures around this rivet line. It doesn't match the schematic we have. Maybe it's a field modification from 44.
Look at the stress fractures around these rivets, right here. I'm getting a high-res scan with the ROV now. The data confirms severe localized pitting.
We need to assess the stress points on this frame before we move it.
Agreed. The corrosion on the lower spar is significant.
Make sure the sensor alignment is perfect. It's calibrated now, ready for the load test.
We need to focus on this stress fracture here before we move it.
Yeah, I see it. It's worse than the initial survey suggested. This section here shows severe stress fractures from the impact. Yes, look at the marine growth embedded right here. We need to preserve this sample. Look at the stress fracture right here.
Yes, the impact must have been significant. We should log the coordinates.
Look at the corrosion pattern here. It suggests a high-impact water landing, likely saltwater exposure immediately after.
These brass clips show significant corrosion, but the underlying structure of the harness tracks remains intact, suggesting a late-war design. Recovered from 70 meters, the team's challenge now is to preserve this rare glimpse into aviation history.